Thank you, Alex. Thank you, Andrea, for the invite. I'm so glad to be here at Vox Bucharest, and I'm so eager that in the next edition we'll be able to be closer together in person, and then after the session we'll be able to share coffee, a beer, or a glass of wine. And today I'm going to be talking about the Java Renaissance, and I'll explain a bit later why I chose this particular title. But I truly believe that we in the Java community, we as Java developers, we are living a true renaissance. Like something good is happening right now, and it's going to shape the future of the developer community for the upcoming years and very likely for the upcoming decades. For those of you that don't know me already, my name is Edson Yanaga. My Twitter handle is in the top of the screen at Yanaga. And I tweet a lot about DevOps, Java, microservices, Kubernetes, distributed data, and related stuff. And some interesting facts about me is that I'm a Japanese Brazilian, born and raised in Brazil, and all of my grandparents are Japanese. That's why you don't see the typical Brazilian face in your screen, but instead me. And also, according to Google search, I was the first person to have the Java Champion and Microsoft MVP titles. I also have the DevConf Rockstar, which is the largest software development conference in Latin America, and they gave me this particular award. I'm so glad to be here during this presentation with you at Vox Bucharest. And since we're talking about the Java Renaissance, I think it's important for us to give us some context. So historically, we had the Dark Ages, and Dark Ages is a part of the Middle Ages, which is comprised between the fall of the Western Roman Empire until the Renaissance, which is the period that we're interested into today. And I know this particular definition of Dark Ages is contested by some historians, but I adapted this definition for the sake of storytelling and analogy, because we want to make some very interesting analogies between the Dark Ages and the Renaissance, and particularly in the period after the Renaissance, which is the Enlightenment. And why do we say it was the Dark Ages? And because we want to make this contrast between dark and light, especially because of the Enlightenment. And the Dark Ages, the main characteristic of this period was that it was comprised of intellectual darkness. Like we didn't have many innovations happening in this particular period. We also don't have like many records of what happened in the Dark Ages. So we have a lack of information, lack of innovation, and also related to the human period, not only intellectually, but it related to other stuff. It also was a dark period because some bad things happened. And one of those bad things that happened in the Dark Ages was, for example, the Black Death. So yes, we had a pandemic, and according to my research, it was the worst pandemic in the human history. It happened in the Dark Ages. It was the Black Death. And I know some of you during the recent pandemic have seen some pictures on the internet of this particular photo that you have on the screen. And what is this picture? This is a picture of a plague doctor. And plague doctor, most of them weren't actual doctors, but people hired by the local governments. And they use this particular mask with a beak shape, which they look like a bird. And the reason for this particular mask is that in the beak, in the top of the tip of the beak, they would add some flowers like dried flowers or some other essence like lavender to be able to hide the particular smell, because you would expect with the Black Death, some of your like fingers or other extremities, they would turn black because of lack of blood circulation. So the smell maybe wouldn't be that pleasant. And at the time, these doctors believed that the Black Death was spread by the smell. So another reason for them to put these flowers and others, like a kind of essence or in the beak, was to be able to prevent the disease. But they didn't treat the patients. Most of the time, these plague doctors were only visiting the people to be able to count the deaths. And that's the best records we have from this particular period regarding the Black Death. So yes, we had this Dark Ages, we had the pandemic as well, so we can like create some analogies to it. And the analogy that I have with the current period, before what we call the Renaissance is that what is really dark, because more often than not in the Java community, in social media, not in the Java community per se, but in particular social media, I see people complaining that, yeah, Java is not a good language, Java is not a good platform. So more often than not, these people are mistaken. So I truly believe that Java, as of 2022, is a very good platform for you to be developing your applications, is a very good platform for you to be using it as your first language if you're learning to be a developer. And I truly believe that Java is a very good language and platform for you to build your career as a software developer. So let's try to put some light on these comments, because most of the stuff that we're reading on social media, they're not based on facts, they're not based on science, they're basically based on some opinions. Or maybe true opinions that people had from Java from 10 years ago, from 15 years ago. And what I want to say to you regarding different opinions, because I know that if you're a Java developer, every time you see like any opinion that is different from you, sometimes we might have some mixed reactions. Some people might get sad, some people might get pissed, some people might get angry. And I'd like to say that for those other people, like with mistaken facts about the Java platform and the Java language as of today, the best way for us to educate those people and to change their opinions is with the right information and with the right tone. So today, I want to give you important facts and important information that you can share with your colleagues, with your friends in the internet and your closed circles, to be able to prevent this spread of misinformation and give them some light of why Java is still a great platform as of 2022. Okay, so that's why we're living the Renaissance. So this historical Renaissance, we have this period where a lot of things happen. We had like a lot of innovation in the art, in the science, in other fields. And in the Java world, we're having this innovation happening right now. So I think today is a very bright moment in the Java history. And even if maybe I may say that we're living the best moment of the Java platform ever, because a lot of stuff is happening and I can see this innovation moving Java forward in the next 25 years at least. And after the Renaissance, we had enlightenment, which again, lots of light, because lots of innovation happens, lots of historical data that we can build upon. And the main takeaways that I take from the Renaissance and the Enlightenment is this quote, sapere aude, which is something that they mention a lot during the Enlightenment period, which in Latin is, we can translate barely in English to dare to know. And the first quote that I have is from Immanuel Kant, when he was explaining the Enlightenment. So what I like to tell you about the Renaissance and the Enlightenment period is dare to know. Like, don't trust other people's opinions just because they are giving their opinion. Dare to know the reasons, dare to know the facts. Go after the real things behind what we're doing. And because of this dare to know, during the Renaissance period, we have a lot of innovation regarding the scientific method. So as of 2022, I think we should be basing our particular opinions, our personal opinions, on science. And when I say based on science, which means that the process in which we're making our decisions should be based on a scientific method. And the scientific method is based on, is focused on empirical evidence and math. And most of the times we're not doing math to prove our point of views, but we can use empirical evidence to be able to get some opinions and reach some conclusions. And what is empirical evidence? Empirical evidence is evidence created by the process of having hypotheses. I think about something, I have some experimental design on how can we prove or disprove our particular opinion. Then after we do that, we can have some peer review, like other people being able to reproduce the results of our experiments. We have like some conference presentation and journal publication. So this particular knowledge can be shared and can be verified by the public at large. That's how we create knowledge. That's a good type of information that can be spread. And how can we use the scientific method to be spreading and sharing the good news about the Java platform? Well, I hope that's what we can do with information that we will be gathering today. So throughout this presentation, what we'll be doing, every time you see a slide with a dark background, except for my personal presentation, you can think about this as misinformation, meaning that this is outdated information. This is from the dark ages, okay? And every time you see a slide with another color, you can think that this is part of the enlightenment. This is new information based on science, based on facts, and something that you can trust, you can reproduce, and you can see for yourself, okay? So dark ages, something is dogmatic, something that people share to you. And people at the time, the representation that we have is people used to behave like flocks, like they say, like they used to behave like sheep. They would just believe in what is happening without contesting some of the reasoning or the facts behind that particular dogma. So with the Enlightenment, we want to have the science behind it. So that's the contrast that we want to make. So in the Dark Ages, we have geocentrism, for example. The belief that the Earth was the center of the universe, which now we know is not true. And during the Renaissance, Nicolaus Copernicus brought us the notion of heliocentrism, which is the sun is the center of the universe and the Earth is just another planet like roaming around the sun. And we also know that today, as of today, this is not true. So even we have innovation and we're constantly changing our beliefs. So we know that the sun is not the center of the universe. It's just another, like, the most important star in one of the galaxies that we have in our universe. But you can see the contrast between geocentrism and heliocentrism. We have new information based on scientific evidence, and then we change our beliefs and opinions about a certain subject. From the Dark Ages, we have this particular opinion. Java is slow. And maybe it used to be true because that's the perception that we had. And remember that whenever we're talking about slow and fast is always based on a reference. So, and based on the expectations that we have on how long does a particular task take to execute. So is it slow or fast? Well, it depends. It must be slower than something and faster than something that we had before. So Java was slow because it used to take some time to do stuff, like to compile your project, to wait for your application to start, for you wait for your application to restart, for you to run your particular task. So Java used to be slow, well, compared to maybe some other alternatives. But I can tell you, and that's why we had some very interesting memes that can be perfectly applied to Java. Java developers, they have a lot of time available because they're always waiting for something to finish. Can be my code's compiling, my application server is starting, my application is restarting. I'm waiting for my Java application to boot. But as of 2022, this is not true anymore because Java is not slow. Actually, when you say slow, Java in production was always one of the fastest, if not the fastest, runtime environment because of the optimizations that we had in the JVM. They were runtime optimizations. As of 2022, we have I think the greatest innovation in the past 10 years at least in the Java community, and not only Java but other ones as well, which is build time optimizations. Because all the things that we used to do as startup time in Java, now we can do at build time. And why this thing is only happening as of today? You might be wondering, well, build time optimization, well, that's a pretty obvious idea. Well, something is obvious after somebody has done it. But before that, nobody thought about it. Or maybe people thought about that, but the technology wasn't mature enough for us to have this right build time optimization. 10 years ago, compilers were much slower than today. We didn't have the right way for us to generate like optimized bytecode and other stuff. So if we had build time optimization 10 years ago, it would be super slow. So Java projects were always like slow to build, slow to compile. When we told people that, well, it's going to take twice the amount of time, people wouldn't use it. But when you say that, now that we can perform build time optimization, now that the Java compilers are super fast, and the build time optimization is going to take like 1 or 2 seconds more than your usual build time, then people are going to adopt that. Then people are going to accept that, because most of the time you won't even note that your build is like 1 second slower. And build time optimization allow us to make Java start super fast, because a lot of the stuff that we used to do at build time, we don't have to do that anymore. And it also allows Java to be much leaner at runtime. Java can be much smaller. And I think that we have some great examples of this innovation happening. I think the best framework that shows how build time optimization can change the perception of how fast Java is Quarkus. But of course, we have other alternative frameworks, like, for example, Micronaut, which, again, science, what I'm saying might be an outdated information. Last time I checked, Micronaut was still using annotation processors to perform their build time optimizations. And on the other hand, Quarkus developed their own compiler to be able to perform even more advanced, even better optimizations at your runtime code. And I'll tell more about Quarkus because that's the one I know. But if you want, like, Micronaut is another framework that uses build time optimization as well to make your projects faster and leaner. But I also want to show you not only the speed to boot and the speed to start your application when you're running, but I think that Quarkus enables you to have this quickness, this fast experience when you're developing your application as well. So what I'm going to do right now, I'm going to go to the Quarkus website. You can go to quarkus.io and you land on this beautiful page. And if you go to the top right corner of your screen and you click on the start coding, you can have this getting started experience. So it's very easy for you to start and to see how fast Java can be on 2022. So I'm just going to type this group ID, Common Red Hat Developers, and the artifact is going to be Vox Bucharest. And I'm going to add just one dependency, just JOXRS to create a REST endpoint, and I'm going to generate that. I'm downloading the zip file, and if I switch here to my terminal, I'll be able to unzip the file that I just downloaded. Okay, Vox Bucharest, and I end here in the folder. Now I'm just going to open my IDE because I want to show you what is development experience as of 2022 of a Java project. Okay, so I have VS Code here, and it's open in my screen. And VS Code also, I believe that is the fastest and lightest way for you to start coding in a Java project as of 2022. And you can see that my Quarkus project has a hello resort, hello endpoint, which is just returning hello rest easy. So what I want to show you is that if I type the magic word here in the CLI, mvn Quarkus dev, I can experience what we call development mode. Because I think that's something that Java was lacking compared to other runtimes, in particular JavaScript. And I know that JavaScript developers, they appreciate a lot the fact that when you're developing, for example, in Node.js, you can have the ability of just saving your file, going to the browser, refreshing, and everything is automatically there. So you have a very short, a very fast internal feedback loop. So your inner build loop, your inner loop, when you're developing applications, you are much more productive. You can be much more effective because you had the feedback of what you're doing in a matter of milliseconds. And I know the Java developers were always jealous because when we were super fast, we used to take like 5 minutes. And if we're using like some plugins like JRebel in the past, which you had to pay for it, you would be able to, in certain cases, like if you're making like minor changes in your code or just changing code inside your method, you would have the same feedback loop. And if you ever tried JRebel before, you know how amazing it was to have this particular feedback loop. Just to change a piece of code, go to the browser, refresh, and everything was there. Or if you're running your test, you could have the feedback of the execution of your test in a matter of milliseconds instead of having to wait for 10 minutes for your test to run. So we really appreciate this short feedback loop because it really makes us more productive. So with Quarkus, as you can see here in your screen, well, it's already running. It took like a matter It took some seconds because it was the first time for me to be starting my Quarkus project, but it's already running. So if I go to localhost 8080, you can see that congratulations, my Quarkus project is running. And if I go to /hello, you can see the hello rest easy message on the screen. But if I go back here to hello rest easy and I say hello Vox to Bucharest and save the file, I go back here, I refresh, and the output is already there. So this is a very short feedback loop. This is an immediate feedback loop that you can make your life as a Java developer much more productive. So in a matter of milliseconds, you can see the result of your changes here in your screen. And I can tell you that Quarkus in particular for my projects, it takes about 150, and when it's very slow, it takes about 450 milliseconds to be able to restart. And it's faster than my local Node.js application, which used to take about 600 milliseconds to start. So yes, you can brag that for JavaScript developers, that your inner loop, your feedback loop when developing Java applications can be even faster than developing JavaScript applications. And what else? Well, this is just for development for this live coding feature, but also with Quarkus, because Quarkus is so fast, because frameworks with build time optimizations are so fast, we can have what we call continuous testing. And I know some of us, we tried continuous testing more than 10 years ago with frameworks with plugins actually, like JUnit Max and Infinitest, which were IDE plugins that allow us to be continuously running our tests in the background. So we would have an immediate feedback. If it's green, all my tests are passing. If it's red, well, I changed something and it broke my tests. So it kind of incentivizes you to be running your tests because you can be even faster because you have like a much shorter feedback loop. And with Quarkus, well, Quarkus is so fast that Quarkus has this built-in continuous testing feature in development mode. So you can see here in my screen, if you look here in the bottom left corner of my screen, you can see that tests are paused. But if I just type R, you see that Quarkus is starting to run the test. And Quarkus, by default, whenever I create this hello world endpoint, it also creates me an integration test. And you can see that in a matter of milliseconds, and actually for the first time it took like a second because it was the first time I was running, so I had to build everything. Quarkus already compiled and executed all the tests, unit tests, integration tests that I had in my code base. And Quarkus is already telling me in red that, yeah, you have one test and it's failing. And let's see why it's failing. If I go back here to VS Code, you can see that I have this greeting resource test. And it was expecting that when you send an HTTP request to the /hello endpoint, the status code should be 200 and the body should be hello rest easy. But we changed that to Vox Bucharest, so let's fix that. So Vox Bucharest, I'm going to fix the tests. I'm going to save the file, and you see that as soon as I save the file, Quarkus is so fast, it's already reran the failing test, and that everything is green. All one test is passing, and it was executed in 372 milliseconds. So that's how fast, that's how short, that's how small can be your inner loop, your feedback loop when you're developing Quarkus. It doesn't matter if you're using the live code feature to see the results of your changes or if you're just running your tests. So I can see in the near future some IDEs integrating with the Quarkus continuous testing feature, so you can have this immediate feedback even in your IDE. So that's how fast Java development can be in 2022. So whenever somebody tells you that Java is slow, well, maybe you should be pointing out, maybe you should be demoing this particular experience as you're developing in Quarkus, because people will be particularly surprised on how fast Java can be as 2022. And can tell that, I don't know if it's the fastest, but definitely one of the fastest development environments that we have in all the programming languages and platforms as of today. Okay. What else? Moving back in the dark ages, we used to believe in this notion from Aristotle that objects fall at a speed that is proportional to their weight. So they used to believe that the more mass an object has, the faster it is going to fall. And we know that today, as of today, we know that it's false, but that's what people used to believe at the time. And during the Renaissance, people realized that, well, maybe it doesn't work that way. So Galileo Galilei, it is attributed to Galilei, that he executed this particular experiment, the falling bodies. So he took different objects or different masses, and then he dropped those particular objects at a certain height. And he observed that those objects, they were falling at the same speed, and they would like reach the ground at exactly the same time. And this particular experiment is what helped Isaac Newton, like many years later, to be able to create this theory of what we call as of today gravity. So we're building knowledge, one fact, one evidence, one empirical evidence after the other. And what else? From the dark ages, we have Java consumes a lot of memory. Java is going to consume the entire memory of your production machine. And to be honest, it used to be true. That's why a lot of people during the Java dark ages, they switched it to other languages, to other platforms, because Java was consuming a lot of memory. And it is world of cloud computing, where you pay but what you're using, and you can see that when your Java application is running, the bottleneck of which VM size that you need to choose in your cloud computing environment, most of the times it wasn't CPU, it was memory. So we were jealous. I used to be jealous, because if people were developing like Go applications or Python or JavaScript applications, they could always choose the smallest VM that they had in the cloud computing provider to be running the applications. And I always had to pay more to run my Java applications because Java required more memory. So if the smallest VM used to be 128 megabytes of RAM or 256 megabytes of RAM, Java wasn't enough. I always would have to pick the 500 megabytes of RAM or the 1 gigabyte of VM, and I used to have to pay 2 times or 4 times more because I needed the memory for my Java application to start, even if CPU wasn't a concern. So that used to be true, and that's what most people still believe this day. They have this notion that Java consumes a lot of memory from 10 years ago. Well, I can tell you that as of today, as of 2022, this is much different. And again, thanks to build time optimization, Quarkus projects can consume much less memory. I can tell about other build time optimization frameworks out there, but I can tell about some statistics that we have from the Quarkus project. So you can see here that if you're using Quarkus and if you use GraalVM, which we'll talk about later, if you compile to native using GraalVM, your Quarkus application will consume total resident size, not heap size. It's going to consume in production only 12 megabytes of RAM. If you use your traditional OpenJDK project, Quarkus is going to consume only 73 megabytes of RAM. And your traditional cloud native stack that you used to developing in the past 5 to 10 years is going to consume at least 136 megabytes of RAM. So depending on how you choose, your Quarkus project can be 2 times smaller regarding memory consumption, or can be more than 10 times smaller. So that's how small Quarkus can be when you're running your projects in production. Okay, and to be able to show you a bit of this experience, what I'm going to do here, I'm going to quit here in the CLI, the amazing Quarkus development mode, and I'm going to build a native image of this Quarkus project. And I know if you ever used it native compilation before, it can be a very complicated process. You need to configure a lot of stuff. But if you're using Quarkus, actually it's super simple. You just need to run your build mvn package and enable the native profile. So Quarkus now is going to build my project and is going to build a native image that I can run on my machine here. Well, in this particular case, it's I'm using a Mac, so it's going to build a native Mac executable, which you'll be able to run later. I'm just showing the screen here because I want to make sure the process starts, because GraalVM sometimes fails to compile my project. But I can see that the project already started and Quarkus performed all the configuration that I needed, but we don't need to wait for it. We can come back later because I have more information to tell you while we're compiling our project. So these are some of the comparisons that we had from the dark ages. So now what you're going to see in blue are some very good reasons for you to share with your community, with your friends, with your colleagues, and to anybody that asks you your opinion about Java as a platform, as a language in 2022. I want to give you good reasons to be trusting the future of Java. So every slide in blue is something that you can share with your friends. First, Java is a very good choice as of 2022 because we have OpenJDK. Java is an Oracle trademark, but the OpenJDK project is open source. So you can go, you can contribute, you can see the source code, you can build the source code by yourself, you can have your own OpenJDK distribution. But if you don't want to compile the project by yourself, you can trust many companies that build OpenJDK binary distributions for you. You can have the Oracle JDK, you can have Red Hat OpenJDK, you can have Azure OpenJDK, you can have like Microsoft, you can have Amazon OpenJDKs. You have a lot of different companies are offering free and open source binary distributions of the OpenJDK project. And in the dark ages, we used to have a new Java version every 2 or 3 years. You can see the pace here from version 1.1, 1.0 to 1.1, 1.2. It's kind of like every 2 years we would have one release. But then between Java 6 and 7, something happened. And for those of you that are old enough, you know what happened in this particular period. Because in between 2006 and 2011, we had the dark ages, and pun intended, that because the sun was setting for Java. So the dark ages, so what we had here between Java 6 and 7 is that Sun became bankrupt and was acquired by Oracle. So we didn't have much investment at the time between 2006 and 2011 when Oracle became the steward of Java. Then we had like the investment back again, and Java was able to finally move forward, and we had Java version 7 release, and then Java 8 and Java 9, and we had a 3-year cadence because a lot of changes happened in those particular versions. But after Java 9, we had the Renaissance. We are in the enlightenment period, because you can see here, because after Java 9, between Java 10 and Java 18, which like latest Java 18 was released this week, you can see that we have a 6-month cadence. So Java is evolving super fast. So instead of having a feature-driven release approach where you would like choose some features and decide that these are the features that are going to be on the next release train, now Java is using a time box approach. Well, we're going to release a new version every 6 months. And what are the new features, new releases that we're going to release on the new version? Well, whatever is ready at the time. So it's much more agile approach. And because we have a new release every 6 months, it doesn't matter if a particular feature misses the release date, because, well, only after another 6 months, you are going to have a new version of Java. Okay, so here we have the Java Renaissance, and Java is evolving super fast. The language is evolving super fast. The platform is evolving super fast, and rest assured that we have a lot of people contributing to the OpenJDK. Of course, Oracle is the steward of newer versions of Java, but you have a lot of companies. So, like Red Hat is the major contributor of OpenJDK after Oracle, and you also have other companies like SAP, like Twitter, like Amazon, like Microsoft. They are contributing to the OpenJDK project as well, so you have a vibrant community moving Java forward related to the OpenJDK. And we have to thank some other companies and some other projects because they helped Java to survive during the Java dark ages. So yes, we still have a lot of Java EE workloads happening. A lot of stuff that we have as of today comes from the Java EE world. We have like features like JPA, like context and dependency injection. Have a lot of good stuff, JMS, a lot of good stuff happened in the Java world because of Java EE, because the Java EE standards moved Java forward. And when Java EE wasn't enough anymore, when we had the dark period, when everybody thought that the sun was setting, Java was dying, like, well, people thought that Java died multiple times ago. Well, we had innovations like the Spring Framework and Spring Boot. They helped Java go through the dark period. They helped Java to survive. So these particular small like innovations that we had in this period really helped Java survive and even thrive in some particular use cases. So we have a lot to thank these particular projects, these companies that helped Java survive and to make Java still compelling as of 2022. And as of 2022, we have much more happening, because I think that in the past 3 years, we're living the true renaissance. So we had this transition period where Java was able to survive, but in the past 2 to 3 years, I think a lot has happened, and a lot is happening in the Java world. For example, GraalVM. GraalVM used to be this thing that, well, allows you to run other languages on top of Java. And there was this module, which is a native image module that allowed your Java applications to be compiled to binary images in the native platform. And it evolved a lot in the past 3 years. So now you can use Java in use cases that you didn't imagine before. You can use Java, for example, to be creating CLI applications. You can use Java to be creating Kubernetes operators, something that people used to use Go to be able to do that. So with Java now you can use binary applications. You can use binary distributions of your particular applications, and it's all provided by GraalVM. So GraalVM like got some attention and is evolving super fast. So yes, for some particular use cases, you can use build time optimization of your Java binary to be executed in your production environment. So it's not ideal for all the use cases, but now, yeah, Java can be used in other use cases that we didn't even consider about using Java before. Okay. And even if you're not developing a CLI or a Kubernetes operator, GraalVM allows you to have some very interesting scenarios. In particular with serverless, whenever you know that your application is not going to be long-lived, if your applications are short-lived, or if you're always scaling up and scaling down your application very frequently, which is not unusual in this new like cloud native, Kubernetes native first world, you can see some interesting facts here. For example, if you get your Quarkus application and compile to native with GraalVM, your Quarkus application is going to be able to boot and reply to the first request in just 60 milliseconds. With OpenJDK, your Quarkus application will be able to respond in less than 1 second. And your traditional cloud native stack is going to require at least 4.3 seconds. So depending on your case, with Quarkus, Java can be 100 times faster. Or Java can be at least like 5 times faster than your traditional cloud native stack. If you add a database to the equation, like Quarkus can start in 42 milliseconds. That's how fast Java can be. With Quarkus and GraalVM, and if you use your OpenJDK, Quarkus is going to take 2 seconds, and your traditional cloud native stack is going to take at least 9.5 seconds. That's how fast Java can be as of 22. So that's another good reason for you to be choosing Java. Now, it doesn't matter if you're using GraalVM or OpenJDK. If you use a framework with heavy build time optimization such as Quarkus, you are going to be super fast. You witnessed that in development mode because Quarkus is running on top of JDK, how fast Quarkus can be. And in production, these are some of the numbers. And by now, my native image is already ready. It took like less than 1 minute to be able to build this native image of my Quarkus project. If I go here to my target folder, you can see here that I have this binary image comprised of 40 megabytes of RAM. So 40 like a total disk size. So this is the entire binary, including all the dependencies for me to run a Quarkus project. And if I run this Quarkus project, let's run this one, runner. You can see yes file allow me to run. You can see that on my machine, my Quarkus project is starting only 24 milliseconds. 24 milliseconds. That's 0.024 seconds. That's how fast and small Quarkus can be. And let's see if my Quarkus project is really running. Localhost. Actually, I can just refresh. Yes, hello Vox Bucharest. And just to measure how much memory my Quarkus project is consuming, I'm waiting for my terminal here to be ready. It's consuming only 22 megabytes of resident set size. So that's how fast and how small Quarkus can be when running your machine or running in production. So yes, Java is fast and Java is small. So don't believe the old tales of Java, the old facts about Java. Believe about science, about empirical evidence. Believe on what you can do and reproduce on your own machine. So I don't want you to trust my slides. I don't want you to trust my demo. I want you to reproduce. I want you to execute your own experiments and experience this particular quickness and smallishness of your Java projects when running in production. What else? Another good reason for you to be choosing Java as your platform as of 2022 is the Java community. The Java community is as strong as always. And I can tell that Java community is not only super big, Java community is growing because of your help. Because you are going to share the good news about Java that I'm sharing with you today, and you're going to excite people. You're going to amaze people with what we're doing with the Java technology as of 2022. So Java user groups, Java is the technology that started this notion of user groups. So that's why we have one of the largest, maybe, if not the largest, user group community worldwide. You can find Java user communities everywhere, and very likely one close to you. And if one doesn't exist yet, well, that's a great opportunity for you to start that. And we also have Java luminaries called Java champions. We have Java champions everywhere in the world. I'm one myself. And those people are helping to move Java forward and are helping to spread the good news about Java. So you can become a Java champion as well. You just need to champion the Java technology to your friends, to your community, in the sense that you are helping those people because they are going to be great developers and they're going to develop great applications. They're going to change people's lives for the better with the code they write because they're using a great platform. And it's your mission to help them, to enable them to their full potential using such a great platform as of the 2022 version of Java. Java is also a great platform because, unlike other languages and platforms, you have the choice of IDEs. You're not confined to a single vendor, a single platform, a single IDE. You are able to choose. So in the Java world, you have at least 4 great IDEs that you can choose to build your project. You have the Eclipse IDE, you have VS Code for Java, the one that I've shown today. You have IntelliJ IDEA, and you also have NetBeans. So just in case one of those vendors, one of those IDEs is not updated anymore, you can get your Java code, you can get your Java project and easily move to another one. Okay, and these IDEs, except for IntelliJ IDEA, they are open source. You can go, you can contribute. They are all have vibrant communities. You can choose your IDE. You can always move for Java forward, and you always have a free and open source Java IDE to be able to code your project. So you are covered. And this competition, it leads to innovation. Every time you have a new feature on VS Code or IDEA, well, the other IDEs, they try to catch up. And the opposite also happens with the other IDEs. So that's what makes Java IDEs some of the best in the market, because we have a lot of innovation happening in this particular space as well. And for beginners, you don't have to buy an IDE. You can easily choose, for example, if you want to teach people how to code in Java, you can use VS Code, which is super small, super fast, and people can start coding Java in a matter of seconds. Or if you're an experienced developer, you're going to be using your IDE for the entire day. Yeah, maybe you have other ones that are your favorites. We don't judge. The important thing is that you can choose, and you can choose what is better for your scenario. I can tell that I use like at least 3 of these IDEs in my daily activities. It really depends on what I'm doing. Whenever I'm doing demos, I think that VS Code is much lighter, much faster to start, much easier to have like defaults configured. So if I want to quickly hack some project that I just download on GitHub, VS Code is my first choice. And if I'm using some coding for a lot of time in one of my like daily projects, then I'm using some other IDE. Okay, so but the good thing here is that you can choose. What else? Maturity of build tools. And if you ever use other platforms, other languages like Python or Node.js or JavaScript, you know what I'm talking about. It's because we have a certain love and hate relationship with the Java build tools. Like we have Maven and Gradle, and love and hate because I know I had the love and hate experience when I'm using, whenever I'm using Maven in the past 15 years, 20 years. Yeah, and you might choose Gradle. It doesn't matter. Both are mature. Both solve the problems, both have issues, and I can tell that these are probably one of the best, if not the best build tools that we have in the markets in any other language or platform. They solve the problem, they are stable, they have issues, but we know the issues, and we know how to like go around those issues to make stuff work. And we have lots of knowledge of the internet. These projects are super mature. You can find answers to your questions anywhere. If you just like search through the web, you can find the answer to your problem, and it will be solved, and it will be an old answer because these are old problems. We've been through that. You don't have to go like be the first one to solve that issue. No, everything is mature in the Java ecosystem. You don't have to worry about that. And because of these build tools, we have an ecosystem, probably the most robust dependency manager system in the world. And I know some people hate Maven Central, some people hate the Maven dependency management system, some people think it sucks until they are faced with another build system. For example, until they try to use Node.js, until they try NPM, until they try Yarn, until they try pip. And I can tell you that whenever I try to use these other dependency management systems, I tell, oh my God, I love Maven. I love Maven because it's dependable. It's reliable because I know how it works. I know that it's going to be there. And you know all of this stuff that happened, like for example, with the NPM packages in the past like 2 years. Then you learn how to appreciate how good the Maven dependency management system is. And just to give you some statistics, we have the Maven Central repository. We have more than 8.5 million artifacts being indexed in the Maven Central repository. That's a lot of stuff. There's a lot of great stuff, amazing stuff there. We have some stuff that is not great as well. And we have all of them open source, publicly available for us to download. And even some other stuff that is not open source, like the Oracle JDBC drivers. They're already on Maven Central as of 2022. So yes, we can build our projects with the best dependency management system in the world. With Java also, we have a set of established best practices. We have the Java community. We've been developing Java projects in the past 25 years. So a lot of the hard stuff has already been solved. Like you don't have to be a pioneer as a Java developer. You don't have to be learning how to solve these new problems. No, because most of the problems are old problems. These are problems that have been solved already. So you can rely on the knowledge of other people. You don't need to make the same mistakes. We have a lot of established best practices. We have a lot of literature. We have a lot of great books. We have books like Effective Java. We have a lot of books like Refactoring, Clean Codes. And you can search the internet for a lot of information about what is the best way for you to create your Java project, for you to be able to do this or do that. It's established. We're not discussing this anymore. You don't need to discuss what is the best Java framework, best Java web framework, because there are dozens. No, things are established. Things are stable. Whenever you choose to do in Java, it's well documented, and you'll be happy doing that with Java. It doesn't mean that we can't always be better. But it's just the point. Whatever you do in the Java space as of today is going to be good. And you can always go one step ahead and make it great. But think about the low, the bar here is that whenever you can do in Java, whatever best practice you find, it's already going to be good. And we can make things great, but I'm happy with good as long as you deliver a project, and I'm sure that it is going to be amazing. Another point about Java is that with Java, unlike other technologies, where you have like seniors with 3 years of experience, with Java, we have really senior people. Yeah, like because we've been doing this with, we've been doing Java development for the past 25 years. So we have some experienced people. We have people that are able to share knowledge. We have people that are able to mentor other colleagues, other friends to become even better Java developers. You can always ask your colleague, oh, I'm having this issue. If he's a senior people, if he's a senior Java developer, he'll have the answer and he'll help you. He'll save you hours and hours of endless debugging or trying to find the best way of doing, because we have senior people that can share and spread that particular knowledge. And I'm not saying that these Java people are old. I'm saying that these people are experienced. And I can tell because, yes, age is part of this evolution process. And I can tell that fortunately or unfortunately, I'm getting in the group of older people, not old yet, but I understand that being older is much better than the other option, which is not getting older. So yes, I want to get old. So, and older in the sense that I can see in other communities that I've been part of, you can see a lot of people competing against each other. People trying to prove that they're better than others. I'm the best. I'm better than you. You have some competition. You have some demeaning comments. You have some conflicts, which are things that we had in the Java development community in the past. But we overcame it. We realized that we're better when we're together. So I can see that we had a lot of fights and arguments in the Java community in the past. I can see that now that the senior people in the Java community, now that they are older, we learned to do better. Now I think we learned that instead of fighting against each other, we all have the same purpose. We all want to deliver. We all want to write great code. We all want to deliver amazing projects into production. So we're here to help each other. And that's a benefit of having these experienced people in the community. And another benefit is that as of 2022, we have Kubernetes native and cloud native approaches. So the benefits of having legacy frameworks like Java EE, like Spring, is that they helped us to arrive in 2022 having Java strong, and they are successful, super successful, because we have projects written in those frameworks and platforms, and they're going to outlast us as developers. We are going to retire before these projects are phased out. But we also have the benefits of 2022 of having a brave new word. Kubernetes, which I've written wrong. I need to Kubernetes, which is, I have a typo here. Kubernetes is here to stay. And I understand that Kubernetes is complicated. Yeah, Kubernetes takes a lot of time for you to be able to ramp up. And after you know enough Kubernetes, Kubernetes is super productive. But you have to go through the pain of learning all the Kubernetes basics and being experienced in Kubernetes. After that is super productive. And being cloud native as well, you have to learn a lot of stuff to be able to survive in this cloud native world. But so Kubernetes is the future. And the legacy stuff, I can say that, oh, can you run legacy platforms on Kubernetes? Yes, you can, because you can always adapt, you can always evolve. But it's like having having a reform in your house. Well, now you want to have different stuff in your house because you have new use cases. You want to adapt, just like myself, for example. I play table tennis and I want to have a nice space, a nice room for table tennis because we need a lot of space. We need a high ceiling, we have good lighting. And well, if you have an old house, well, you have to break some walls. you have spent a lot of time adapting, and maybe the result will be not optimal, but you keep living in your house while you're doing that. Like, you don't throw away your house, it's running, you live there, you're reaping the benefits of it, you adapt and you move forward. It's different from what, oh, I want to create a new house. And I know what I want. So we're going to design the house with these particular features that are going to be a perfect match for what I want. So that's why you have these benefits of these new frameworks, such as Quarkus. They were created for this new world. They were born for cloud native and Kubernetes native. So we don't have to adapt everything. Everything is tailored. Everything is super optimal. Everything is easy when you're using Quarkus, for example, if you want to run your application in a cloud native world or in a Kubernetes native world. So I have very few minutes. So what I want to show you is that if you want to use Quarkus, I'm going to stop here to run and deploy your application to Kubernetes. And I won't be able to demo this today because I'm almost out of time and I want to be able to answer some questions if you have. But if you want to deploy some Quarkus applications to Kubernetes, all you have to do is a matter of like creating a container. I just have here a doc container image. I have the Kubernetes extension. I have the Kubernetes also. And just by adding these particular extensions to my project, I'm able to create a container and to deploy to Kubernetes. Okay, what I'm going to do here, Quarkus is downloading those extensions and adding that to my project. And what I want to do, I'm going just to copy and paste some Slack. I want the image registry, group, and name. And just by doing it, I can easily create a container image just by typing mvn package Quarkus container image.build equals to true. I can build a local container image of my Java project, and I would be able to deploy this Quarkus application on Kubernetes just by applying a very simple YAML file that Quarkus is going to create automatically for me. What is hard about Kubernetes? Well, creating the YAML files and having to deal with YAML files, I think, is the major burden that we have in Kubernetes. Well, what do we have a tool that can do all the hard parts for us, and we can focus on the nice part, which is running our application on Kubernetes, like benefiting from Kubernetes? Well, I have a container image here, like I use a Docker on my local machine to create a container image with my Quarkus application. Didn't have to do anything, and also Quarkus created the Kubernetes YAML file. So I just need to apply this YAML file to my Kubernetes cluster, and it's already running. And if you want to test your Quarkus application very easily in a free Kubernetes cluster, I recommend you to go to developers.redhat.com. And if you go to the Red Hat developer website, you can see this link here in the top called Developer Sandbox. If you click here, you have access to a free Kubernetes cluster for 30 days. You can just need to click here on the red button. You have a free environment for you, a multi-tenant environment for 30 days. And once your environment expires, you just have to go back here and click the button again. You have another free environment for 30 days. Right? So these are the key takeaways that I wanted to share with you in this presentation today. I just want to move you to my last slide, which has a dark background, but it's not from the dark ages. I like to think that I'm here for the Renaissance part, for the enlightenment phase, and I hope I was able to share some evidence that you will be able to reproduce the experiments by yourself at your home, and you're able to see that, yes, Java is still amazing as of 2022, and Java is going to be even greater. Java is already great, is already amazing, but it's going to be even more amazing in the next 25 years. Java is here to stay, and I hope you enjoyed this presentation. I hope you enjoyed the Java of 2022, and I hope you will be able to share this good news with your colleagues, friends, and your community.
Thank you very much, Edson, for your presentation and for allocating the time for being with us today. I'm looking through the chat, and the crowd is quiet right now, but I'm sure they can reach you at Yanaga on Twitter if they will have any questions. All the talks are recorded, They will be on YouTube, and they can reach you afterwards. So thank you very much for being with us today, and I hope that next time we will meet in person at the next version of Workdays.
Yeah, I know everybody had a great day. It was an awesome but also tiring day. I know it's end of Friday for you, and I hope I was able to entertain you for the last hour and wish everybody, of course, you had a great Vox request, so wish all of you like a great Java experience and have a great weekend.
Thank you. Have a great weekend, and see you soon. Bye bye, Edson.